My name's Teresa Chapman. I'm beginning the second year of my PhD program at the University of Colorado, working under Dr. Tom Veblen in the biogeography lab. My specific interests lie in forest disturbances and at the landscape scale, so at very large scales, what's going on in terms of fire, insect outbreaks, the regeneration of new forests. So Colorado is in the midst of one of the largest documented ever mountain pine beetle outbreaks, really the largest insect outbreak that this area has known. Over 2 million acres of lodgepole pine, also now limber pine and ponderosa pines, are being killed by this beetle. And at this scale, 2 million acres, Coloradans want to know what the next forest will look like over the next 100 years. What will this turn into? What kinds of trees are going to be coming in after this outbreak? Are there any hazards that come along with this outbreak? Questions like that. So I'm studying the regeneration that's following this intense mountain pine beetle outbreak. What I'm looking at are what seedlings are actually establishing in the past 10 years. So we're in the midst of also of a long-term drought, a very dry period. And this dryness could also be influencing the ability of a new forest to regenerate. And so even though we have the death of a mature forest, we want to know what is going to help create a new forest. And are the conditions right now that also created this outbreak also kind of restricting or limiting the growth of a new forest? We have a large area in Colorado that is covered by lodgepole pine, which is the main host species of the mountain pine beetle outbreak. So that's the tree species that has suffered the most mortality in the past 13 years. And we are not seeing a large number of new lodgepole pine seedlings coming in the understory of this dead forest. What we are seeing is a subalpine fir and species that grow better in the shade. So we have a lot of dead trees. They're still standing. There's still a lot of needles, dead needles, twigs covering the ground. And lodgepole pine does not grow well under those conditions. And so what we're seeing is a lot of more like a shade-loving species coming in, which will be a very different forest than the pine forest we're used to. So the shade-loving trees will do just fine. They will take the opportunity to grow even faster now that they get more sun. It's really getting them started in that understory that gives them the advantage over the pines. So the standing dead trees, right now they're rotting at the base, so it's actually hard to see when they're going to fall. It looks like a solid piece of wood standing, but if you were to push on it, those roots are rotting and they just snap right at the base. I would say in the next 10 years, most of them will be on the ground. We expect in the next 10 years, the trees that are currently standing and dead will fall to the ground and lie there and rot, probably within 20, 30 years, unless a fire comes through, expediting that process. To date, there is no scientific evidence that the mountain pine beetle outbreak and the conditions it creates increases fire risk in the forest where this outbreak is occurring. It's a very naturally dense forest. At high elevations, you have high tree densities, and given the right climate conditions, those forests will burn hot, dry, high winds, regardless of if the trees are live or dead. We have one example here in Colorado where in 1997, 10,000 acres of trees fell to the ground in a single blowdown event. And in 2002, that same forest was burned in a lightning ignition. And the areas where the trees had fallen to the ground prior to the fire did burn more intensely. So the fire was hotter there, maybe stayed longer in one place, but it didn't change the actual risk of having a fire. I think the aesthetics of the future forest is an interesting question because it depends on your perspective. A lot of people see this as a natural process, the birth of a new forest. A fir forest is going to be a beautiful forest too. Could take 30, 40, 50 years for those trees to reach the height of the current forest. However, it is a different forest. There will be logs strewn all over the ground. And that, I'm afraid, I can't change people's perspective on. In addition to subalpine fir being part of this new future forest, we will also most likely see an increase in aspen in many areas where aspen is currently existing. It could be equally hard for aspen to establish and regenerate in the shaded understory with a really thick litter depth, similar to lodgepole pine. So it would depend if aspen was there ahead of time, it could extend up root suckers, but if not, if it had to establish from seed, we may not see that as much. We'd like to look into that. I think that soil moisture and climatic conditions will be the most influencing factor in the regeneration of our future forest. Drought conditions are not favorable to any tree species. And so the lack of regeneration of tree seedlings could largely be due to extremely dry conditions. And that's true for all species, including aspen and fir. I think the best thing students can do to support forest health, at least at their own scale, would be things that all politicians and probably environmentalists are saying: a local impact, ride your bike, don't drive 2 hours to ski, reduce your consumption, and try and make whatever effort you can to stop global warming. I mean, when we come right down to it, global warming is the common denominator in a lot of these issues: increased fire risk, increased beetle outbreaks, lack of regeneration of seedlings. I think forest biogeography and disturbance ecology right now is probably one of the most fascinating fields to be a part of, because we're at a time where the forest is changing so rapidly, and we're documenting these changes, many changes that people probably predicted, over 30 years ago. I'm able to come and study and hopefully make predictions for the next 50 years. Optimistic ones, I hope, but it's just a fascinating field. There's so much going on right now in disturbance ecology, documenting the past and trying to predict the future. My research could influence management policy. The lack of lodgepole pine regeneration that we're seeing, although we haven't analyzed the data yet, just visually you could walk through a beetle-infested lodgepole stand and not see any new lodgepole seedlings coming up. It may require some prescribed burning, really low-level surface burning, just to prepare a favorable site for the lodgepole seedlings. So I'm just trying to document what's going on naturally, and hopefully management will take that and use it to build policy and prescriptions. So lodgepole pine is considered a very classically adapted, fire-adapted species. It has cones, pine cones, that stay shut when they are mature, and they can stay on a tree for decades. And so when a fire comes through, the fire opens those cones and releases millions of seeds to the forest floor. Now, if we have less lodgepole in our forest, we will lose that adaptation and that resilience to building future forests after fires. So I'm holding a branch from a lodgepole pine that has this closed cone habit. And you can see here that the cones are hanging on the branch and all the scales are sealed shut. And so when a fire comes through, it's going to open those scales and let the seeds fall to the forest floor. So following a fire, these seeds are released from these cones. However, following a mountain pine beetle outbreak, we don't have the opening of the cones and the release of seeds to the forest floor. We also don't have those favorable site conditions. We have really thick litter. We have a lot of shade. So the forest conditions are completely different for lodgepole after a fire versus after a mountain pine beetle outbreak. And I'm trying to study what exactly are the differences that are most important to getting lodgepole to establish after a disturbance event. So another aspect of my research is looking at lodgepole establishment after fires. And in 2002, we were in one of the worst droughts in the past 500 years. And there were major fires across most of Colorado in many different forest types, and a lot of them occurred at high elevation in lodgepole-dominated forests. I visited these sites this summer, and although the data is not analyzed, you see very few lodgepole seedlings coming up even after fire, which is kind of the classic response of lodgepole to fire. So we're trying to figure out, why don't we see a lot of lodgepole seedlings following these fires in 2002? Was it too dry? Too hot in 2003, 4, and 5, and 6? So any existing seeds and germinants were killed in the following years? So those are big questions for the future that we'd like to answer. The formation of a meadow after a fire, let's say 50 years from now, we have a couple surviving lodgepoles and that area burns, we may have the formation of a meadow after a fire like that. We may not get that typical response of lots of little seedlings coming up after a fire. One consequence of the current mountain pine beetle outbreak may be that following future fires, we have very few tree seedlings establishing in those areas due to either that we don't have a lot of lodgepole in those areas, and so we lose this kind of classic fire adaptation, the closed cone releasing the seeds, and we have a fir-dominant forest, which really doesn't have that same ability to respond quickly after fires. The majority of trees that don't have these closed cones have just open cones, so when a cone is mature, it just opens and it releases the seeds that fall, and then the seeds overwinter and germinate the following spring. And that is the typical, life cycle of a cone into a seed into a tree. However, the closed cone is a unique adaptation. It's found in a couple of tree species that allows this quick response after fires. It's called a canopy seed bank. Trees are important in maintaining our carbon balance. And so the idea that we may have less regeneration of trees after future fires would throw off that balance. Currently, we kind of assume that when a forest fire burns through an area, we replace that area with new trees, and it kind of maintains this equilibrium. So wildfire at least, isn't really included in carbon balances globally. However, if we're not replacing the forest with new trees after a fire, that will change how we look at fires, altering carbon balances. And the death of the trees alone right now, in terms of the mountain pine beetle outbreak, is already becoming a carbon source rather than sink. The trees are decaying across Western North America. So if you take the number of trees across Western North America that are being affected currently by the mountain pine beetle outbreak, it's on the order of over 20 million acres. British Columbia alone, I think, has 15 million acres of dead trees. And so these trees are decaying, and instead of taking carbon out of the atmosphere and photosynthesizing, the carbon is now being broken down and released into the atmosphere. So we're turning into a source of carbon rather than a sink, which would be taking it in and building biomass. And this additional carbon, carbon dioxide is one of the major greenhouse gases, and so added carbon to the atmosphere will only increase warming. So it's part of that positive feedback loop where warming is maybe increasing the mortality of trees, which then creates more decay and decomposition, which feeds more carbon, which then can heat the globe more. One concern of future forests may not be the mountain pine beetle in the next 50 to 100 years, since they have killed all the mature trees that they like, but there are other smaller beetles that have faster life cycles. So the Ips beetle, it's a very small beetle, and it feeds on ponderosa pine, lodgepole pine, but it can attack very small trees and can produce new beetles 3-4 times in one summer. And so under global warming conditions, we expect these smaller and maybe historically less influential beetles to really become primary killers and mortality agents of the surviving trees, the smaller trees, the weaker trees. In fact, right up on Niwot Ridge, we already see an increase in the Ips beetle activity killing the lodgepole pine. I think beetles will be a principal element in any study of future forest. I just want to emphasize that this research is ongoing and that these are current hypotheses that we are investigating. And although policymakers and land managers have to act now in response to the mountain pine beetle outbreak and to things like fire risk, we are still trying to draw connections between mountain pine beetle, fire, what the future forest will look like, what are the consequences of this outbreak. So a buzzword right now in land management is resilience. Managers would like to manage for greater resilience in forests, so the ability to withstand disturbances, recover quickly from them, survive droughts. You know, what does that mean? What sort of density, tree density do we need to survive droughts? That's a hard question to answer. But my research is looking at, you know, the ability of forests to recover following a disturbance. We know that fires will happen in the future. We live in, you know, Colorado. We have lightning strikes. We have conditions under which trees burn. What will allow managers to help create a forest that can recover after these fires? How do we get lodgepole seedlings growing in this new forest? I think many people, you know, most of Colorado probably lives in the Front Range, and we really don't see how devastating the mountain pine beetle outbreak is on the western side of the Continental Divide. If you went up north of Steamboat, that whole area, the mortality is upwards of 98% of the lodgepole pines have been killed. It's hard to imagine that. I mean, you look at a hillside, it almost looks like Vermont in the fall because it's maroon, because the entire hillside is red. And I don't think people have grasped that aspect of this outbreak. They go up to Rocky Mountain National Park on the eastern side of the divide, up by Long's Peak, and it's still very patchy. And you think, oh, it's not that bad. But it's variable.